Hi everyone, welcome to today's webinar, Accelerating Analytics with EMR on your S3 data lake. My name is Amelia and I will be your moderator. Before I introduce you to our speaker, I have just a few housekeeping items. All participants are automatically on mute throughout the session. We will be using Slack to communicate, so please take a moment to join us on the community Slack channel, which is copied into the chat box, and it's alluxio.io/Slack. However, if you are having trouble joining Slack, feel free to message me your questions via the GoToWebinar question feature on the right-hand side of your screen, as well as the chat box. We will have a Q&A session at the end of each section, so we can answer all of your questions. To ask a question, again, you can either join the Slack channel, or if you're having any trouble with that, you can feel free to message us your questions via GoToWebinar. Lastly, today's session is being recorded and will be available for on-demand playback. We will email you the link to the presentation as well. That's it on the housekeeping items, so let's meet our speaker. We are very pleased to welcome Dipti Borker. Dipti is the VP of Product and Marketing at Alluxio with over 15 years experience in data and database technologies across relational and non-relational. Prior to Alluxio, Dipti was the VP of Product Marketing at Kinetica and Couchbase. Dipti holds an MS in Computer Science from UCSD and an MBA from Haas. Without further ado, passing it on to Dipti.
Great. Thanks, Amelia, and thanks everyone for joining today. We'll be talking about a very exciting topic today, analytics using EMR, AWS EMR on your S3 data lake, and how you can speed up your jobs, your Spark, Presto, Hive jobs on your EMR clusters. So let's get going. What I'll talk about today, there's a few different sections. We'll talk about EMR first, what it provides, the capabilities, some of the challenges that users see with EMR and using S3, and how Alluxio can help with some of those challenges. We'll then dive into a demo. So I'll bring up an EMR cluster bootstrapped with Alluxio, and we'll take a look at a few different commands in Spark and see how it all works integrated together. And then we'll take a little bit of a deeper dive within Alluxio itself to understand some of the technical capabilities. We'll take a look at the architecture and answer any questions along the way. So do feel free to ask questions along the way, and every now and then I'll stop and take a look and check in for questions. So let's get going. First off, S3 is an incredibly popular data tier and increasingly being used as the default data lake in many different environments. As data platform teams think about how they create their modern data architectures, they're looking at a couple of different options. If they're in the cloud, they're looking at different cloud services, the mega clouds, and for AWS, S3 is not only a popular storage tier, but is also a very simple API that many different technologies are now integrating with. And so with S3, you get a highly available storage service that has a very simple API. It's an object store underneath the covers, and so you have simple puts and gets. You have some metadata operations as well, and it's fully managed for you, so you don't really need to worry about how many instances, how many nodes, things like that. It's taken care of for you. It's available in every region. It's available in every region as well, and so you can access S3 through any different region. Trying to see if seems like screen share is frozen. Start sharing over again. Let's see if it works now. Right, let me get into full screen mode. There we go. And so there's many different advantages for S3 in general. And so if you're on the webinar, you're likely already using S3 as your object storage, as your data lake, and are looking at EMR in terms of running analytical workloads. So EMR is a very powerful analytics service that AWS provides that comes with a range of options. you can bring up a cluster of 5 nodes or 500 nodes with a single CLI command or with a click of a few buttons, and it's configurable. So that means that you can bring up many different types of services within the cluster itself. As an example, here you see that you have the Spark service that's brought up in every node, a Presto service, and a Hive service. And by default, you get the HDFS layer as a file system layer, as well as EMRFS from a storage perspective, and we'll talk a little bit about that. All of these clusters, all of these nodes within a cluster are integrated together, so they basically look the same. Every node looks the same, and you have a single master that is coordinating the entire cluster. Now EMR has added capabilities for high availability on the master as well, and as they get more mature, many services like Alluxio will integrate into that HA capability to provide, which is important for longer running clusters. So EMR has the ability to store data in a couple of different ways. The first one is if you use HDFS. If you use HDFS to store data, you can store this temporarily while the cluster is up, and it provides somewhat like a caching capability for your workloads. However, it doesn't sync automatically down with S3, and so as you write data to HDFS, you may need to manually sync data using commands like discp periodically for your workloads. So in this case, HDFS is on every node, but there are challenges with syncing back to S3 if that's where you want to persist your data that's generated from your workloads. It also provides the option of EMRFS, and EMRFS is basically a thin layer on top of S3 which provides an HDFS API so that your Hadoop-based frameworks can directly work with S3 without any code changes or API changes. And EMRFS also has an optional capability for consistent views for metadata, which means that you could create a DynamoDB table, which can store your metadata so that you get consistent access to that S3 data. So this is how you could use your EMR cluster. You can bring up a cluster, pick the services that you want. For example, if you are only using Presto, you could bring up Hive and Presto. The Hive, you would need Hive for the catalog service, and you can bring up Presto. Or you can bring up Spark for running your models, creating ETL jobs, and others. And so every EMR cluster can be configured independently. Now, in terms of S3 itself, running analytical workloads on S3, whether it's Spark or Hive and others, there are a couple of challenges that users see. The first thing is that object stores in general have metadata operations like list and renames, and the behavior for these operations is a little bit different than a typical file system, and so these can be quite expensive directly working with S3. In some cases, you also might see eventual consistency. And given that S3 is a highly distributed storage, there might be that's multi-tenant in some ways. You might see performance discrepancies. So if you're looking for consistent performance for your workloads, it may not be the case. Every time you run a workload, it might take a different amount of time. Sometimes it might be an hour, sometimes it might be an hour and 20 minutes, and so it's harder to get consistent performance. In addition, there are throttling limits, and so every S3 bucket and prefix has certain number of limits that are a part of S3, and so you might see situations where you might get S3 errors like a 500 or 503 errors when the service may not be available, or you need to slow down access to S3. So in order to deal with these challenges and get performance that's consistent, Alluxio provides a caching layer on top of S3, that can be part of the EMR cluster itself. And so whether it's Spark or other frameworks, you get a data caching layer that's co-located within EMR, similar in some ways to the options that are in EMR. But you get strong consistency for your metadata operations by default because Alluxio caches not only metadata, but also the data. And so you get both with a single service. And it's compatible with HDFS, with S3 APIs, as well as it provides a POSIX API if you bring up services like TensorFlow, which are now available within the EMR service. And in addition to that, you can also move data outside of S3 within your EMR cluster, like a remote HDFS. And we'll take a look at what that might look like in a couple of slides. So Alluxio basically at a high level is a layer that sits close to the compute, but between compute and storage. And whether it's S3 or whether it's other storage systems, you can bring data, mount data into Alluxio using the HDFS drivers or the S3 drivers on our southbound side, as we call it, and make this data available via various APIs on the northbound side to a range of different frameworks. So let's see what happens when Alluxio is brought into the EMR cluster. Alluxio provides a metadata and caching layer within EMR. And so we'll take a look at the demo. I'll show how easy it is to bootstrap an EMR cluster with Alluxio. So you can run a simple create cluster command and bring in Alluxio and have it deployed within every node of EMR, and so that it's configured with all the class paths and everything already set up for you. And so once you have Alluxio within the EMR nodes, all the services on top can directly talk to Alluxio, and Alluxio can sync data back down to S3 as needed. In some situations, you might have workloads that don't need to be where data is generated, but you don't want it to write to S3. In that case, you can store data only in Alluxio and use it as just a cache. If you want to write data to S3, but you want to asynchronously write it, that is, don't wait for a consistent write, you can do that. Alluxio provides an asynchronous API that can write data back down to S3. So the client gets a response as soon as the data is in Alluxio, and then Alluxio job service will write it down to S3 asynchronously. Or you can pick a synchronous write down to S3 in situations where the data is extremely important and you want strong consistency between Alluxio as well as S3. So there's a few different options available on the write path. On the read path, if the data is not in Alluxio already, it will get pulled in from S3 into Alluxio and then served up to the service on top, or to the frameworks on top. And once it's in Alluxio, it's cached and it'll be there until it's evicted or it expires. And so until then, it can be used over and over again with high performance. So for workloads, particularly training workloads like Spark jobs that are running the same model over and over again on the same data set, it can be extremely useful because in this disaggregated environment, you now have data locality on every node, on every single node within the EMR cluster. So let's take a look at how the caching would actually work. Let's say you get a data request to read an object from the trades bucket. First, what happens is that object gets pulled in to Alluxio, and then it gets sent back to Spark. And if you get a request for that object again, it's already in memory, and it gets sent back to the framework directly from memory, and so that makes it faster. You can also pin data within Alluxio for specific table data that might be heavily used, maybe across frameworks. And once it's pinned, it will stay in memory. It won't be evicted. And so this data then gets sent over across to whichever framework is asking for it. And so that's how within a single node, you get strong data locality. and you get tiered caching. Here I showed you an example where data was pulled into memory and then served out of memory. But Alluxio does allow for tiering. And so not only can you use memory within an instance on EC2, if you want, you can choose to use only the SSD tier. And not the memory tier, and keep the memory tier for the frameworks that are running on top. So if you're using Spark caching for smaller files, or for RDDs, intermediate RDDs, you could use memory for those, and then use SSD for the Alluxio tier to achieve that locality for remote data or for data that's in S3. So let's take a look at an example in terms of what happens when the RAM capacity is full and you need to move data across tiers. So with intelligent tiering, what happens is, let's say we have the same request again from a customer's bucket. We are out of memory from a RAM perspective, and so the evictor actually comes in based on the high watermark and low watermark. Will move this data to a lower tier, let's say SSDs, and then the data will be fetched, once there's room, the data will be fetched in and served out of memory. And so now that data is cached, and for future requests will be served out of memory. In terms of tiering, the way it works is we have an evictor that has a regular interval that it runs at. That's configurable, and the data gets moved. Alluxio manages all these layers, RAM, SSD, or disk within the instance itself on a per worker basis. And so that way, not only can you leverage the memory, the additional memory that you might have on your EMR instances. If your instance type comes with an attached SSD, you could use that as well to store data and manage data to provide increased data locality. In addition to this, Alluxio 2.0 comes with policy-driven data management. What that means is you can actually set policies within Alluxio based on date created, as an example, and once that policy is actually run, the data will actually be moved from one storage system to another storage system. So let's say we define a new policy here where data that's more than 90 days old needs to be moved from a remote HDFS into S3. Or if it's you could do it less than 90 days old if you want recent data in S3, depending on whatever your dimension that you're trying setting is, as well as where you want this data made available. And so based on this policy, let's say the interval is every day. That interval can be changed. When the policy is applied, it'll be applied every day, and that data will be pulled in as it's being based on that policy, and the data will move locations. You can have different actions. For example, you can do a move. You could perform a copy operation if you want the data available in both the locations. And since Alluxio can mount and read data from not only S3 as well as HDFS, you can bring in data from your remote HDFS into your EMR cluster and run EMR in a hybrid manner. So not only can you run EMR on your S3 data lake, you could extend it to run it on your S3 data lake as well as any remote data that you might have on premise or in a different region, a different zone, etc. Now, Alluxio comes with different APIs. It's flexible in terms of the APIs, and so for every framework, there's different approaches. For Spark, you could just if it's a text file, you would just run it, convert it to an RDD in this way, give it the URI. In this case, it's the Alluxio URI, and make it available within your Spark context. For Presto, for example, you can create a schema and then provide the location as an Alluxio URI, so that it uses Alluxio as the storage tier. Similarly, we have the POSIX API, which is very useful for TensorFlow and Python-based frameworks. Simple operations like cat, etc., would work. And then for Java, if you're writing Java code, we have a Java API that's pretty extensive, and you can write your own Java applications using OpenFA, OpenFile, Get, etc., to bring data and write data to and from Alluxio. So let's take a look at how Alluxio can actually be bootstrapped into an AWS EMR cluster. Here's a simple create cluster command. So you see here that similar to what you might do without Alluxio, you have a release label which picks the EMR version. You can pick the latest version or a specific version that you want. Instance count is the number of instances that you want to be created. And so if you say 3, then you have 1 master and 2 workers. If you say 5, then you have 1 master and 4 workers. In this case, you can also give a custom AMI ID. And this AMI ID happens to be the ID of the Alluxio AMI in the Amazon Marketplace. And so that you can use the Marketplace AMI directly in creating a cluster and get the benefits of the data orchestration and the policy-based data management, as I mentioned just a minute earlier. You can provide an instance type, pick an instance type that is available for the AMI. The AMI is available for certain instance types. And then you can pick your application. So you can pick Presto, Hive, Spark, etc. For the demo, I'm going to use Spark as an example and run some simple commands in the Spark shell and see how it can be used. And then you give it a cluster name. The cluster name is whatever you want to reference it by. You provide some bootstrap actions. This is where the path, the actual path of the bootstrap script goes in. We have a bootstrap script that's available. It's in an S3 bucket, and I'll show you what that looks like in just a minute. And then finally, your key pair that you have. So here's an example. You have, let's say I'm using the 523 release for EMR. In this case, I'm using M for extra larges. I give it a name. I give it a path. In this case, it's an older script. We have a default version 201 script that you can use. And then you give it a URI. So this is this is S3A, the folder path that you see here, that becomes your root directory under Alluxio. And if you have data here, it automatically gets mounted and accessible to Alluxio. So let's actually jump into the cluster and EMR console and see what's going on here. So here's the EMR console. By default, you can just create an EMR cluster very easily. Here you see, similar to the CLI command, you can give it a cluster name. You can pick the applications that you want on it. You could pick core Hadoop, instance type, number of instances, and so on. I already have an EMR cluster that I've created using the Bootstrap script waiting here. But just so that you can see it in action, let's give it a try. So I have a simple command here that will be run. That you see here. It will use the Bootstrap script that I have. This is the location for it, and it's a public bucket. So Alluxio public EMR 201, and that's the script. And all the configurations are within a JSON file that's also within the same bucket. And so you see the same file here. And I am going to create a cluster here with an M4 2 extra large. With 5 number of instances 5, so that's 1 master and 4 workers. And I'll give it a name, webinar test 2. And get going. So let me save this and run this command. When you run the command, you get a cluster ID. You'll see the cluster ID here, and it'll start off creating the actual cluster. So if we go back and refresh our console, you'll see that I already had one that's ready, and a new one is coming up. It's starting up. And it'll take a few minutes. It takes a few minutes to instantiate the nodes. It'll bring up the EC2 nodes. It'll install a bunch of software, including Alluxio on every node, and get going. So this might take anywhere from 5 to 10 minutes, depending on EC2. And so for now, what I'm going to do is actually use the cluster that I already have. let's take a look. Let's go into it and see what the configuration is. So if you go into hardware, you will see the instances that we have. So I have one master here, and I have two workers. And for this, I have used the R5 extra large instance type. So you can pick an instance type that the Alluxio AMI provides. So if you actually go into the marketplace and you search for Alluxio, you'll see that you have the caching for data analytics, AMI, and you can go ahead and subscribe to it. That's the way to get started. Once you've subscribed to it, I have already subscribed, so I already see that it's available. Effective date is today. And so now, once this AMI has been associated with my account, I can go ahead and use it to configure my cluster. So when you go into the configuration window, you actually see the AMI ID here. Depending on which region you want, you can pick the AMI according AMI ID. So let's say it's a West 1, which is Northern California. It'll give you a new AMI ID. That's the ID that you would put into your create cluster command that we just ran. So now that we have the cluster up, you see that this is the cluster that I have up and running here. If I go into the master, I get the public DNS for it. So using this, I can SSH into the cluster. So let's go ahead and SSH into the EMR cluster. So you see that now I'm within the cluster. Once I'm in the cluster, let me get my cheat sheet up here. You can make sure that Alluxio is installed and Alluxio is running. And so a simple way to start off is an Alluxio fs mount command, which will basically show you what the root directory is. So if you remember, I had pointed to this bucket as my root directory. That's where Alluxio kind of starts off, and it'll have access to everything under this directory, this folder within that bucket. If you run tests on Alluxio, you will see that it's a simple utility that runs some basic operations to read files, write files in many different modes, whether it's using, with caching, with async through different write types and so on. And you will get to know that, okay, everything looks good, the test passed, and you now have you'll probably see a new directory there, which is default test files, which was created with this test that ran. Now, I also have another file that's stored here called the sample2g. So basically, this is a 2 gig file. It's a 2 gig text file. And what you see here that is, it says 100%. And what that means is that this file has already been pulled into Alluxio. And because I had run a few tests before, and what I'm going to do now is actually run a free command on this specific file so that it actually gets evicted from the Alluxio cache, and it's only available now on S3. It's not within Alluxio. So if I run the ls command again, you'll see that this will now say 0%, which means that it's no longer within the Alluxio context. So now let's get started by running. Let's bring up the Spark shell. Oh. It'll take a minute here just to bring up the Spark shell. And once that's up, what we're going to try to do is read that file directly from S3 using Spark, and then we will read the same file a couple of times from Alluxio, and we'll see that once it is in Alluxio, the read will be significantly faster. So here I have within my understore, I have that sample2g file, and I'm going to read it as a text file into Spark, and then run a count on that text file, and you'll see that we get started. This is using Spark directly on S3 and not using Alluxio yet. So it'll keep going. The times vary quite a bit for this command. Even today, I've been running it a few times, and every time I get a significantly different time. So here you see that it's 23 seconds. Now let's try to do the same thing within Alluxio. So now I point to Alluxio, and I ask for that same sample 2G file to be read in. And I'm using a different variable just to make sure you understand that's using S3 and this is using Alluxio. So let's do that. And then I run the same count on that file, the Alluxio file. That's getting pulled in. And if you remember, we had run the free command on this file. So we had run the free command initially, which meant that this file was no longer in Alluxio. It was only in S3. And so it is pulling that data into from S3 within Alluxio, and it's it takes 10 seconds. Now, if I run the same command again, which is a count command, it takes even less time. So let's take a look at the comparison. So when we started running Spark on S3. It took 23 seconds. Then we tried it with Alluxio, and in this case, Spark goes through Alluxio, but the file is not in Alluxio yet. The file gets pulled from S3 into Alluxio, and that takes 10 seconds. And then once the file is in Alluxio already, it takes even less time. So you'll see that you'll get pretty consistent results depending on once that file is already in S3 within Alluxio cache on the workers. So this is kind of a simple example of how Alluxio could improve performance of a Spark workload. In this case, it's a simple count example. Obviously, Spark workloads are a lot more complex and read a lot more than 2 gigs of data at a time. Sometimes it could be hundreds of gigs or terabyte of data per job, depending on what you're running. And so this gives you an example of how different that performance could be. All right, so let's get out of the demo here and back to our slides. One thing I wanted to show is, actually we can do a write example as well. So S3 has a nice console that's available for you to actually browse your folders and files. And so if you remember, I had this Dipti Alluxio 2019. Within that, I had an EMR folder. Within that, I had UFS folder. This UFS folder was the folder that I had made into the root UFS for Alluxio, and you see here that the sample 2G file, the default test files got created as well, and so you can browse using the console to get an idea. Now let's run. The one thing I forgot to show you is the Alluxio UI. So, we've been running some ls commands and so on. You can actually bring up the Alluxio UI on this is the same master DNS, public DNS, and it's on port 19999, and that's where you can basically bring up the Alluxio master and see what else is going on. So you see here that you have we are running 2 workers, one master. It has an uptime of a couple of hours right now. It gives you some visibility into the space used. You can browse the files here as well, and you can see all the file paths that are within Alluxio, the logs. So you have the master log, the audit log if you have auditing set up, diagnostics log, and so on. You can also see all the configurations that have been applied. So for this cluster, let's check the write type. So the write type is cache through, which means that it's synchronously writing back down to S3. And let's actually run quickly a write command as well to see how that works. You can see that there are two workers here. You can see space per worker and usage per worker, and other metrics that you might be interested in. So in case of Kubernetes, you might see the domains. If you're using outside of EMR, domain sockets is for Kubernetes. You can see short circuit writes, remote writes, etc. And so you have a lot of metrics that you can take a look at within Alluxio. So that's the Alluxio UI when if you want to browse through the different files and configurations. Now let's go back to my little cheat sheet here, and let's try to I exit my Spark shell already. Let me bring the Spark shell back up, and let's try to write these files now back down to S3, directly to S3 and through Alluxio. So it'll take another minute for the Spark shell to come up. Let's create our variables here. So this is first. Let's do the write using S3, and so Spark is going directly to S3. I'm doing a save as text file, and I want to save that that file. Just make sure that this is new, just in case I have it already there. Okay, so it starts it off, and it's going to write this down. It's 2 gigs. It'll take a little bit to write this out. Next, let me just, in the meanwhile, copy my Alluxio location here. So this is still going. Any questions, Amelia, so far? While we wait for this to get completed?
Yes, we do. We got a couple of questions here. Our first question is Alluxio useful for both short-running and long-running jobs?
Yeah, absolutely. So, EMR clusters in general are used for many different types of workloads. Typically, what we see is that if they're used for Spark, they might be ephemeral because you run a Spark job, whether it's an ETL job or a training or model training job. You might run it for a period of time and take it down. And so in that case, it is an ephemeral cluster. You can also run it. You can also use it for long-running clusters, and we've seen that is the case for either Hive or Presto workloads. So if you have a BI tool or your analysts that are using a Presto cluster, that might be long-running. And using the Bootstrap script, we actually have the ability with our latest release to actually write out our embedded journal. So when you shut down the cluster, if you want to maintain the context that was in Alluxio, you can actually write that embedded journal and save it. And then when you bring up a cluster later on, you can actually import that journal and bring up a cluster warm. So you already have the context that it's from the previous run. So yeah, you can use it for both ephemeral as well as long-running jobs.
Our next question is, what are the options available to persist Alluxio cache between different EMR runs?
Yeah, so as I mentioned, this is more about if the question is about the journal and the context within Alluxio, we now have an option. So just like we are using the Bootstrap script, you can actually use the shutdown script or the stop script and actually write out that journal, and that will maintain the Alluxio context. And you can then import this journal when you bring up another cluster so that you have the data already in there. All right, looks like our Spark job completed. We'll take more questions in a little bit. And so, it took some time to write this file down. Now let's try it using Alluxio. And remember that this is still using cache through, which means it is not an asynchronous write. An asynchronous write would have been even faster. And so let's try this out. And again, I'll make sure that EMR test, just rename it so that make sure that the folder doesn't exist already. Okay, and then Alluxio is going to now try to write this file back down to S3 synchronously. And it'll take a little bit as well. Okay, let's actually go to the console and see what's happening here. So let me refresh this. Now we should see some new folders here. So this was the one that we wrote via the, so you see that there's probably created like 62 splits. Yes, that's the one that wrote directly through to S3, and then this is the one that's writing via Alluxio, and it has we have our block size is 512 MB, and that's what you see here. If you can update the block size. We see the performance. That's the default, but we've seen in many cases that if you reduce the block size, the performance actually dramatically increases as well. And so you can try that. You can see that this adds up to roughly 2 gigs. And that's the file that we're writing on. All right, so this is already done. And so you see the time taken in this case, and the time taken, writing down to S3 directly. So it's about maybe roughly 3x. So let's go back to our slides and talk about the architecture really quick before we take some more questions. So as we saw with Spark, there's a couple of advantages to using Alluxio. You can have multiple jobs that use Alluxio so that your context is maintained between jobs. And Alluxio brings back your data locality within your EMR cluster, which is lost when you have a separated data lake that you're using. And so use S3 as your data lake, but get more performance essentially and the ability to pull in remote data using Alluxio within EMR. We support many different APIs, as I mentioned, and we also have a unified namespace. So once you start using Alluxio and you mount maybe HDFS, remote HDFS, local HDFS, S3, all the apps really need to use just one URI. Even if the data moves around, the application itself doesn't need to be changed. So here's a quick look at the architecture of Alluxio. In the context of EMR, Presto, Spark, all these would be in a single cluster. Here I've shown 2 different clusters. So you have a Presto cluster that might be separate and a Spark cluster that might be separate. And Alluxio is typically a part of that running on the compute cluster along with the compute. And so you see the Presto workers and the Alluxio workers running in the same instance or the same container. And then the object store or the HDFS is remote. We have high availability within Alluxio. You could either use the Zookeeper or you could use the RAF protocol. And so you could have a master and 2 standbys or 3 standbys available for HA. And within the worker itself, we have tiered storage, as I mentioned earlier, as well as you can partition the cluster so that you can have certain nodes used only for certain clients speaking only to certain sets of nodes, either to split across different frameworks or to make sure that you're talking to nodes that are within the zone and the availability zone that you are in, if the cluster is across availability zones. All right, so we talked about this already. Here's a look at the unified namespace. And so in this context, this is the root URI. In the demo, I used the EMR /UFS folder in an S3 bucket as the root URI. And so it automatically could access everything underneath that and made it available to Alluxio. You can have nested UFSs as well underneath that root UFS. And so, if you have many different storage systems, this is sort of what it might look like. You have Alluxio, you have HDFS, maybe an object storage, S3, NFS, another HDFS. It kind of all looks like one big file system, one big virtual file system. It's important to know that not all the metadata gets pulled into Alluxio. Only the metadata that's needed is actually pulled in. And so that might be 3%, 5%, 10% of your total data set. It's not all the metadata that's on S3. So with that, I want to open it up for more questions. Alluxio is an open source project as well, incredibly fast-growing community, and a lot of action on our Slack channel, as Amelia mentioned earlier. So feel free to join that. It's Apache 2.0 licensed and we have our AMIs, which give you the flexibility of using it on an hourly basis as well. So open it up for more questions at this point.
Great. We have a couple questions. In the meantime, you're welcome to send more questions into the GoToWebinar questions box. So our first question here is, can we run Alluxio outside of EMR?
Yes, of course. This webinar was focused specifically on EMR, and so my demo as well as the talk was focused on EMR. But you can run Alluxio outside of EMR, and we see a couple of use cases for that. So one is, if you're running all in the cloud on AWS, you could have a native install. What that means is you might be running Apache Spark cluster separately directly on EC2. Maybe you have your CloudFormation templates, etc. And so you can use Alluxio to improve performance of those workloads as well. You could either use the AMI, and we also have a CFT that you could use and create a standalone Alluxio cluster, or install the Alluxio workers along with your Spark or Presto or your basically any compute frameworks that you have. Install Alluxio co-located with those the workers of that framework. You can also run it on other clouds outside of AWS. We see GCP, Azure, and also within your data center. A popular use case within the data center is running satellite clusters outside of HDFS. So many times we hear that HDFS clusters are typically fairly overloaded, but they still want more compute capacity without adding more I/O on the HDFS cluster. And so many times we've seen that users have created a Presto Alluxio cluster in a remote data center that is pulling data from the other data center where the primary HDFS cluster is located. So there are several use cases for running Alluxio outside EMR as well.
Great. Our next question here is, can we run multiple Alluxio clusters at the same time on the same underlying S3 bucket?
Yes, you can run multiple clusters. You might have to be careful for writing write-based workloads. For read workloads, it's a good use case because you might have a separate Spark cluster, a separate Presto cluster that might be reading the same data, and you can make that available and accessible via Alluxio. In case of write workloads, you want to make sure that you have you take care of how your writes are being performed, especially if they're async writes, because that might mean that different workloads are overlapping. This is nothing specific to Alluxio. That's something you have to take care in general for as you're running write-based workloads.
Our next question here is, do you see any challenges for using Alluxio on Kubernetes platform?
Yeah, good question. I didn't really talk about Kubernetes here today because within EMR, there's no Kubernetes as such. It's already managed for you. But if you are running a standalone Spark cluster within Kubernetes, Alluxio can be a part of that. And typically, so Alluxio has its container, a Docker container. You can essentially bring up that container within the Kubernetes environment and use domain sockets to make sure you get tight data locality between the Spark or Presto container and your Alluxio container. So Alluxio works really well within Kubernetes. It continues to be an area that we're improving on from a product perspective, and you could use a daemon set approach so that you're running Alluxio on all the cluster, on all the nodes within Kubernetes, or you could set up replica sets and use labels so that you set it up on maybe just the Spark nodes. And so there's a few different options with Kubernetes. We also are now adding Helm charts and other integrating with other tools to make it even easier to work with Kubernetes.
Great. Our next question here is, does Alluxio provide high availability mode?
Yeah, so Alluxio does provide a high availability mode. Within EMR, EMR recently added, very recently added HA capabilities. And so once they get a bit more stable, we will look at actually integrating HA with EMR specifically. But outside of EMR, we already have HA enabled. And I'm trying to pick up the architecture slide here. Yeah, so we have HA enabled using multiple standbys. That's for the metadata. We also have availability, high availability in some ways for the data itself. Data can be replicated within Alluxio across the workers, and you can have anywhere from 1 to infinite copies. So you could have a copy of a file on every worker, if it's important, or you can have one copy across the entire cluster. And this is configurable on a path per path basis. And so not only do you get you have availability, and a file can be highly available within the worker. You also have high availability for the master and the metadata itself.
Great. Well, thanks to the audience for all the great questions. And I do want to mention again, if you have any additional follow-ups or other questions later on that you would like Alluxio experts to respond to, or the broader Alluxio community, you can feel free to join the Slack channel at alluxio.io/Slack. And I want to thank Dipti for hosting today's webinar, and thanks to our audience for joining us.
Yeah, and one last thing I want to mention is we have a great tutorial for you to get started. If you can paste the URL into the chat so that everyone has it, you can simply go to alluxio.io AWS-tutorials, and this gives you all the tutorials we have for AWS, including for EMR, including the CloudFormation template, and additional usage on EMR. Here, AWS. And so on the EMR tutorial, you will see that you have step-by-step instructions, starting with subscribing to the Alluxio AMI in the marketplace and getting going, as including running the cluster command, so logging into SSHing it, running the cluster command, etc. And then this uses Presto as an example, and I'll take you through some steps to create a table, create a database, create a table using AWS Glue, and reading and writing from it. So it's a great way to get started. Hope you guys find it easy, and we always look for feedback. So if you have any questions, feel free to reach out to us via Slack, or reach out to me personally, Dipti at alluxio.com. Thanks, everyone. Thanks for joining. Take care.